Good morning, friends. My name is Sanjeev Kumar. I am Senior Corporate Trainer in Koenig Solutions. For several years in Koenig Solutions, I am delivering trainings on several security products like Checkpoint, FortiGate, Palo Alto, F5, and others. Today, I am going to discuss about spoofing and how different vendors handle the spoofing. And also we'll see how it is a problem in a normal firewall environment. To understand what is spoofing and how it is a problem, let's try to draw a picture, a diagram here. Suppose this is a firewall and the firewall has three interfaces. This is internal network, this is public network, and this is a DMZ network. Internal network is having this 192.168.1.0 subnet, and public network is definitely a public, and in DMZ you have a web server that has the IP address of 192.168.2.10/24. Okay, so in this firewall uh, you are going to create a rule so that internal user can access internet outside. So I'm going to create a sample rule for this kind of requirement. According to my rule, which I'm going to write in a firewall, I am defining that if a traffic is coming from this network and it has a destination as any, service as any, and action is allow. Okay. Now this can be a sample rule which will allow 192.168.1.0 users to go outside to access internet, right? Yes. So using this rule, definitely people from inside, they can go and they can access anything outside, and their reverse is also allowed through state table of the firewall, right? Obviously. Now we need to understand how spoofing can be dangerous to the firewall. For for spoofing, uh, for spoofing to understand, try to consider a user here outside. This user with yellow color has a machine. This machine may have some public IP address x.x.x, but with the help of spoofing, this user is going to use one IP address. With the help of spoofing technique, it says, or it emulates that its IP address is 1.11, and with this black colored spoof IP address, this user is going to access the DMZ server. So this is the intention of the hacker. Now we need to look into the rule and decide whether this communication will be allowed. Yes, it will be allowed, because in the source, any packet which comes from 1.0 So 1.11 also belongs to 1.0. So from outside, the packet is going to be accepted to any destination and any service. But is that something we needed? No, it is not required actually. So this is something spoofing, right? And this is a problem for a simple firewall environment. Different vendors have used several techniques to fight with this kind of trouble. When we talk about Palo Alto, I would say that they have adopted the concept of zones. So what they did, they created two more attributes in their rule table called source zone and destination zone. So once they define that if a packet is coming from trust zone to untrust zone, then only this rule should be applicable. So by mentioning the source zone and the destination zone, so this zone is your trust, this zone is your untrust. So if a packet is moving in this direction, then only the packet is going to match this rule. If the communication is reverse, as it is in the case of hacker, the source and destination zones are not matching. Hence, the packet is not accepted. So this is one of the solution Palo Alto used to deal with your spoofing. Similarly, FortiGate have defined source port and destination port. So instead of zones, FortiGate says that you need to mention the source port and destination port. Means the traffic is received on this port and traffic should exit from this interface. So for example, if for example this interface is say ETH 0 and this interface is ETH 1, then in the case of FortiGate, in your rule you have to mention uh, source port and destination port also. So you can say the source port is say uh, port ETH 0 and destination is ETH 1. So in that also they controls the direction, right? So apart from Palo Alto and FortiGate, Checkpoint vendor uses a different methods to deal with it. Although the basic concepts remains the same. So in Checkpoint, what they how Checkpoint handles it, in Checkpoint uh, we define something called topology. Okay, in the topology we know that we have interfaces say ETH 0, ETH 1 and ETH 2. Now we have to mention that what are the valid source connected with ETH 0 and what are the valid source connected with ETH 1. Similarly for ETH 2. From this, my example, ETH 0 is connected to 192.168.1.0. So on Ethernet 0, the firewall expect packets with only source 1.0, 192.168.1.0. And if a packet comes which has any other source, accept it, then the packet is spoofed. So this way the checkpoint handles it. Now I'm going to show you the options, how you can uh, control the spoofing in checkpoint. So okay, now here you can see This is the dashboard login for Checkpoint. So as a user, as an admin, actually, I'm logging in, and the smart dashboard is launched. In my smart dashboard, I have only management server right now. So I'm going to add the gateway, means the firewall. So I'm I'm going to add the gateway by putting the IP address and name, and with the help of communication button, as you can see, I'm going to establish the trust. So as I click communication, it requires the SIC password to create a trust. I provide it, and as I say initialize, it establishes the SIC trust, and then gives you the information about those IP address, which are about those network which are connected through these of the interfaces of Checkpoint firewall. So uh, now you can easily understand that from the example of ETH4. So ETH4 is connected with 192.168.13.2. Okay, it means 30.0, 13.0 will be the network connected to ETH4. So any packet which is received on ETH4 must have source 192.168.13.0, and also this subnet is not allowed from any other interface, right? So if I check it and all connected interface are connected to the right network, I can accept it. Also, let me tell you, that is not, the one time, this network to interface management is not one time. You can do it later on also. So if I want to say ETH2, you can see ETH2. Now I'm going to modify the situation of ETH2. So I'm going to select the modify, and now you can see this ETH2 interface is pointing to the internal network. And I know because this interface leads to the DMZ, I can modify later on also. So I select override. Once I override, I have an option. I have these three options, say not defined, and interface defined by interface IP and net mask, and specific. We need to understand that uh, if you have a firewall and firewall is connected with the internet, so you have no idea that through Ethernet 0 how many IPs are coming. So if you have no idea how many networks are there, what are the valid network sources on that interface, you can select not defined. But if you have clear idea that this interface is connected with the network 192.168.1.0/24, so you can select this second option, and you can define, uh, you are not required to define here manually. Automatically whatever IP address is configured on the interface, say 192.168.1.254, is going to uh, define this network, that this network is a valid network from this interface. And in third situation, there may be a case when you have one network and then other network and then have other network, say three different networks connected with one interface of the firewall. Then you can simply create the objects like network 1 as an object with 1.0 network, network 2 with 2.0, network 3 with 3.0, and you can make them a group, network group, and then you can put this group here. So your firewall will be aware that what are the network sources that the firewall should expect from that interface. Okay. Now, I think you people have got good idea about what spoofing is and how it is handled. That is all from my side this time. Thank you for watching. See you in next video.